In this video we're going to look at the fundamentals of National 5 Maths. We're going to go through the sort of stuff that comes up every year almost. And if you can't do this stuff in this video, you're in trouble. It's absolutely essential that you are able to do all of the things that we go through. And we're going to fly through quite a lot in this video and just cover all of the most important areas. It's not sufficient. You have to do far more revision than simply this video, but it's a good start and should check that you know the basic theory involved in everything. It's like we're repeating the course very, very quickly and focusing on the most important stuff, the stuff that is always assessed. Okay, so let's start with fractions. I can struggle to imagine a year in which fractions are not asked about. So here's the fundamental concept you have to understand. And once you understand this, you'll never dream of adding fractions that don't have a common denominator. So say we have a half plus a quarter. And I don't mean to be patronising, but once you've seen it this way, you will always add it properly. So a half plus a quarter, different denominators, and the correct answer is 3/4. So if we look at it, there's a half, there's a quarter, we put these together, and of course we're going to get something that looks like that. That makes sense. Whereas if we do a half plus a quarter and just add them, so 1 plus 1 is 2, 2 plus 4 is 6, you get a half plus the quarter, and you're saying this plus this is this. It's completely absurd. So when people see it in this form, this seems natural to them, just add them. But if you actually draw it out, you see how ludicrous this is. So it's absolutely essential that you get common denominators when you're doing additions. And we're going to do an example of this. Let's come on to a clean sheet and do a couple of examples where we play around with fractions. So here's kind of a worst case scenario. So you imagine you had something, a big bracket like this. 2, and you've got a quarter in there, and you're dividing this by 3/4. You're taking all of this and you're timesing that by a half, and then this whole thing here you're adding 3/7. So you really have to understand your brackets. So what can we do with this? Well, we can start by doing this multiplication. This is the first thing we should do. That 2 can go up here. 2 times 1 is 2. So let's just rewrite that. So we've got 2/4 divided by 3/4. When you're dividing, it doesn't matter about common denominators. And then we're timesing this by a half. And then we're adding 3/7. Alright, so how do we do a multiplication? The rule for multiplication is you flip the second fraction, you multiply. So let's just do that. So 2/4, flipping this one and timesing 4/3. Now, the astute among you may have noticed something that we can use. We can notice, well, there's a 4 there, and 4 there, they cancel, so we're left with 2/3. When you have the same thing on the top and the bottom, you can just score them out. Because 4 divided by 4 is 1. Hence, so we've got left with 2/3 times 1/2 plus 3/7. Again, multiplying doesn't matter. You just do top times top, bottom times bottom. 2 times 1 is 2, and 3 times 2 is 6, plus 3/7. Okay? These have different denominators. So the way to do this is we take this 6 times top and bottom, then this 7 times top and bottom. So we're doing 2 times 7, which is 14, 6 times 7, which is 42, plus 6 times 3 is 18, and 6 times 7 is 42. So this magic trick gives you a common denominator every single time. This denominator multiply top and bottom, this one multiply top and bottom of the other fraction. Every single time you get the right denominator. And this gives you 32/42. However, this method doesn't give you it in the simplest form, so you're going to have to simplify. And now, you've probably been taught this in a slightly different way, and we'll probably look at how that way. But for now, let's just show you actually what you're doing and why this works. So 32/42, well, this is the same as that times 1, which is the same as 32/42 times 0.5 divided by 0.5. 0.5 over 0.5 it's 1. Anything divided by itself is 1. So this is true. And we've not changed anything. We've just times it by 1. Same thing, no difference. This is perfectly allowed in maths. And the result is that you get 16 over 21. Now let's look at the standard way of simplifying. Say we had something horrible like 528 over 18. What we can do is write out the things that divide 18. So 18 divides by 18. This is not leaving a remainder. Divides by 9 to give 2. Divides by 6. Divides by 4. And divides by 2. So you can check this. 18, these are all the numbers that will divide it. Now 528, well, you maybe have to use a calculator, but you can see that can divide by 2, doesn't divide by 3, but divides by 4, divides by 6. We've got 6 here, 6 here. So divide top and bottom by 6, so we do 5, 2, 8, divided by 6, divided by 18 over 6. I put brackets in, so this looks scary, but it's not. It's just do this, and you're left with the fraction, and that leaves you with 88 over 3. And so that concludes our look at fractions. So let's go in and move and look at scientific. Right, so scientific notation, this is the little explainer that I've got here. So I'm just quite fond of doodles. So the correct form is something dot something times 10 to the power of something. Alright? Not something something dot something. You see the difference? It has to be like 5.2, it can't be 15.3. It has to be one number dot one number and then the power. That's the correct form in scientific notation. So let's look at how it's kind of working here. So you've got 5.0 times 10 to the 9. This is essentially saying we're doing 5 times 1 billion, which 5 times 1 billion is of course 5 billion. This 10 to the 9 is you're saying you're timesing 10 times 10 times 10 times 10 9 times, and that gives you 1 billion. Another example here, say you've got 50 times 10 to the 3. 10 times 10 times 10 is 1,000. So really what you've got here is 50 times 1,000, or in other words, 50,000. And well, 50,000 is the same as 5 times 10,000. And 10,000 is times 10 to the power of 4. So you see how we've turned this into not scientific notation, because it's got something something like this, which is the big not here, and it's turned it into something in scientific notation by adding 1 to the power. So if we want to move it kind of in this way, so it's kind of push this from 50 to 5.0, so push it along that way, we have to add 1 to the power. So we're turning 1,000 into 10,000 by timesing by 10 again. So that's the basic principle. Let's look at a very quick example of this in practice. Switch in another bit of paper. Commonly asked to multiply in scientific notation, so doing something like 5 times 10 to the 8 times 2 times 10 to the 4. So you multiply the numbers, and then you take the 10 and you add the powers. So when we look at powers, you should probably know this by now, but when you are working with powers, you add the powers. So this is leaving you with 10 times 10 to the 12, and well, we're not allowed to do that because this is the big thing with a not in it. See, this is this something something. We can't have that. So we want to move it this way, and how do we move it this way? We add 1 to here. So we're left with 1 times 10 to the power of 13. That is in scientific notation. Okay, let's just square this off and move on to something different. Let's have a quick look at vectors. Just a very quick passing. There's not a huge amount you have to do about vectors. A lot of it is figure out yourself. But here's the basic theory you need to. So when it comes to vectors, there's a couple of things you need to know. Say we've got something very simple, like so. Let's say that this is B, this is C, some arrows in like that, that's A. So we can write things like A to C, like this, A to C with the arrow going this way. Well, that's equal to, you go A to B, there, plus there. So you can make statements like that. There's often problems based around that kind of basic concept. Also, you've got to be able to do operations. So we have things like, say, 1, 2, 3. This is how you write vectors. This is the x component, y component, and the z component. Now we could say add 3, 5, 7 to that. Nice and simple. 1 plus 3, that equals 4. 2 plus 5 is 7. And 3 plus 7 is 10. Nice and easy. We can multiply these by numbers. 1, 2, 3. 2 times 1 is 2. I've got 4, 6. Nice and easy, just do things by components. The other thing we often have to do is find the magnitude. So if we called this, say, u, the magnitude of u, so we take each of the numbers, we add up the squares of the number. So 2 squared plus 4 squared plus 6 squared, and take the square root, and if you do that, you'll get 2 root 14. This would tend to be a calculator kind of question if you had to, well, maybe not. You could work that out yourself actually. Right, so let's move on to some other stuff that you have to be able to do. So often you're having to work with graphs and equations of lines. So say you had a graph something like this, and well, you know this has the equation y equals kx squared. There's no plus c because this is nice and going through the origin. And remember that any point on the line has an x and a y coordinate. So if you're given a point, you have information. You know that at some value of y, you're going to get an x value, or some value of x, that's the corresponding y value. So you have useful information that can be extracted from a point. And we're going to see things we can do with this. And you can rearrange. Often you'll have to be asked for k, and you can do a simple rearrangement. You can say that, well, k equals y over x squared. So if you were given a point, let's say the point 2, 2, you can quite easily find k. You can just say that k is 2 over 2 squared, which is, of course, 1/2. See, the squared cancels, the 2 cancels, so you get 1 there, so you get 1/2. Nice and simple. Perhaps you have to find an equation of a line. And we can find the equation of a line if we're given 2 points. Say we're given the point 1, 3 and the point 3, 7. That's all we need to find a line. We have an x point and we have a y point. We don't have to even find gradients and things like that by finding the gradient y2 minus y1 and all this nonsense. That's one way you can do it, and you may be asked specifically to do it that way, and you should do it that way. But the other way we can do it is we can say that this is y equals mx plus c, and we can solve this by simultaneous equations. You have to be good at this, so we might as well do it. So you can say, well, this is y1 x1, so this forms one equation, this forms another equation. So we can just substitute 3 for y equals m, well, m times 1 is just m, plus c. And we can also say from this equation that 7 is equal to m, well, 3m, x is 3m plus c. And we can subtract these equations this way, so you can do 7 minus 3. What's 7 minus 3? That's 4. 3m minus m, that equals 2m, and c minus c is 0, so hence m is equal to 4 divided by 2, and 4 divided by 2 is not wildly difficult, it is of course 2, so we have the gradient 2. Now we can substitute back in here. We can say that 3 equals, well, our m is 2, see, I'm just using this equation, plus c, and it doesn't take a genius to work out that c is 1, and this is our equation here. Put these back in, these values we've got, what does that give us? That gives us the equation y equals mx plus c, sorry, that's the form, and so y equals, substituting, we get 2x plus 1, and that's our equation. And just might as well do this for completeness. We say that m is y2 minus y1 over x2 minus x1. So this is x1, this is y1, this is x2, that's y2. So substituting, we get m equals 7 minus 3. Remember, we already did this calculation. And then we're getting 3 minus 1, and that is 4 over 2, so m is 2. Exactly in the same way. So there's two possible ways to do this. And then you would do exactly the same thing to get c. You put it in that equation, rearrange for c. Very easy to do. So there's some stuff that we have to do involving graphs. You also have to be good at working with percentages, and percentages are put in to trick you. So let's have a look at a problem involving percentages. Let's throw that away. Alright, so let's say a kind of standard question would be something like, you pay, say, $50. This is 20% more than last year. And then, so the question is, what is last year's payment? And this is an evil trick question, and everybody gets it wrong all the time because they do it the wrong way. They say, oh, we'll just take 20% off this. That's completely wrong, don't ever do it. Don't just times this by 80%, percentages don't work that way. They work in more complicated ways. And so the correct way to do it is to use this formula. Percentage change equals new minus old divided by old times 100. Let's just, for this example, we'll call it x. So we're looking for x. What's the thing, the original? And percentage decreases, you have to sugar around this formula a bit. So we've got percentage change is 20%, we've got 50 minus x divided by x times 100, and we can easily solve this, divide across by 100, 20 divided by 100 is 0.2, get 50 minus x over x, so we get times x. So you're just rearranging equations. Alright, let's do some more, get everything on the same side. So we've got plus x equals 50. So this is 1.2x equals 50. And, well, what do we do with this? We get x equals 50 divided by 1.2, which equals 41.66. And you can do a check here and make sure this works by doing your answer 41.66 and times that by 1.2. This 20% increase is 1.2, and that gives you 50. So always check, and you can say that's correct. Now that we've done percentages, we can move on and look at statistics. Within statistics, the most important things to know are how to find the mean and the standard deviation. There's more within National 5, this video is not completely comprehensive, but they are the most important, and if you can't do them, you're really in trouble. But they're extremely easy to do. So let's look at the mean. Mean is extremely easy. Essentially all it is basically add them up, divided by count them. It's a simple, highly simplistic way, but accurate to describe it. And just look at an example. Say we do 2, 6, 5 and 3. Very easy to find the mean. Let's simply add them up. 2 plus 6 plus 5 plus 3. Count them 1, 2, 3, 4. Divide by 4. So if you add them up, you get 16 over 4, and that simplifies down to 4. Now let's look at the standard deviation. Standard deviation equals the square root, the summation of some point x minus the mean squared over n minus 1. Essentially all this formula is saying is take the square root of, once you've, and basically add up all of the differences between a point and its mean, square that. So you're adding the sum of the squares of the differences of the mean. Sounds complicated, but it's not. Then you're adding them up, subtracting 1 from it. Very, very, very simple. And I'll show you just how simple it is. So we've got example 2, 6, 5, 3, and we've got our mean. We'll put that down there. And so we take the difference. So 2 minus 4, well, what's that? That's minus 2. Then here, 6 minus 4, that is 2. 5 minus 4 is 1. 3 minus 4 is minus 1. Then we square these. So what's this? That's 4. Then 4, 1, 1. When you square a negative number, it becomes positive. That's why you're doing this. You want the absolute difference. You don't care if it's greater than or less than the mean. It's not important. You want the difference. And then we just sum them. So 4 plus 4 is 8, plus 1 is 9, plus 1 is 10. So there we go. Sum these up. Just add them all up, and you get 10. Nice and simple. Now this is basically what we've got here is this. So this can go into here. So this becomes 10 over 4 minus 1. 1, 2, 3, 4 as before. Square root. And that's the square root of 10 over 3. And that comes out to about 1.83. And that's how you do standard deviation. So let's move on and let's look at some powers. Powers are extremely important, and then we'll look at surds. Surds are very important. They always come up. And if you don't understand these, again, you're in trouble. So the rule is you multiply. When you're multiplying two things, the rule is you add. And when you're dividing, the rule is you subtract. And that's the powers. So dividing two powers, you're subtracting the powers. Multiplying two powers, you add the powers. For example, x to the power 1/2 times x squared. And that is x to the 2/2. 2.5. So that's a half plus 2. And we don't tend to write it like that. We would say x to the power 2.5 is more standard. Now let's move on. Let's say we've got x squared over x cubed. So that's x squared minus 3. Or rather, like that. So we're doing 2 minus 3. And then that is x to the minus 1. And you should know that that is 1 over x. When you've got a negative power, it goes in the bottom. For example, if you've got x to the minus 2, that's the same as 1 over x squared. X to the minus 3 is the same with 1 as over x cubed. Nice and simple. You see the pattern. So let's look at surds. Surds are very important in National 5. They always ask about them. Square root of x, what's that? This is x to the power half. So we're seeing how these surds are related to powers. So you've got a 3 in here, so the cube root, that's x to the power of a half. A third, sorry. And if we've got a 4 in there, that's x to the power of a quarter. So you're seeing the pattern. This number's going there. What if we had x cubed and the 7th root of x cubed? Looks very bizarre, but actually this is just the same as the power of 3 over 7. See, this goes to the bottom, that goes to the top. Nice and simple. Right. What things you have to do with surds? You have to know how to rationalise the denominator. So we wouldn't tend to write it in this form. We'd like the surd on the top and a sensible thing on the bottom. And the trick we can do is we can say, well, that is the same as 2 over root 6 times 1. Just multiply by 1. Not difficult. We're allowed to do that. We can multiply anything by 1. Doesn't change it. And 2 over root 6 times root 6 over root 6. Well, what's anything divided by itself? It's 1. This thing here is just 1. All we've done is multiply by 1. We haven't changed anything. That's why root 6 over root 6, you can multiply anything by that and do nothing, because it's multiplying by 1. And root 6 times root 6 is root 6 squared, which is, of course, 6. The square root just vanishes. And so you end up with 2 root 6 over 6. And you can simplify it. You can say that that's root 6 over 3. You see, we're just combining these we don't need to multiply the top by 2 and divide by 6. It's easier just to divide the whole thing by 3. These cancel down. Right, last thing you have to be able to do, say you have root 72, you can split this up into this times this. And what are these numbers? Well, what's the highest number that's, you want this one to be a square number, and you want this one just to be something. Right? Not square. So 72, the highest number, if we try dividing this by 2, then by 3, then by 4, and just keep going down there. And so we get 36, and here we get 2. 36 times 2 is 72, so this works. And root 36, this is a square, this is 6 squared, so we're left with that. We'll go on and do it. So here's the next one. Say we've got root 96. Well, that can be split up. So we're wanting a square number here, and then another number here that's going to stay as a square root. So 96 divided by 2, no, that's not a square number. I would divide it by 3, no, and just keep going down until you find a square number. And eventually, when you divide this by 6, you'll get 16, which you should recognize 16 is 4 squared. And then in here, we can put 6. So 16 times 6 is 96, 16 squared is 4, and then we're left with the root 6. So that's how we can divide these things up. You keep dividing this until you find a square number, and then you put the thing that you divide it by here, and when you multiply these two things it comes back to this, and since this is a square, you can take the square root and you get a number without a remainder. And that's basically the idea behind these. Nice and simple. Right, what we're going to do next? Well, I think we can look at how to expand brackets and a little bit of factor. So we'll take an example, we'll multiply it out, and then we'll factorize it back again, and we should get what we start with when we factorize it. So let's take the example x times x plus 2 squared. Now when we've got squared, we can write this out twice, so we can say that this is x plus 2, and then x plus 2. We multiply it out as so, we multiply this by this. The x stays out front, so we get x squared. Multiply this by this. Essentially we're multiplying everything by everything else. And plus 2x, and then the 2 times the 2 is plus 4. And then we can take the x and multiply the x by each thing. But first, we'll combine like terms. So these are both in x, so they can be combined to form 4x. 2 plus 2 is 4, plus 4. And then as I said before, this x can multiply like this. This is essentially x to the power 1. Remember our powers, so this is x to the power 1 times x squared, so it's 1 plus 2 is 3. So you're going to get x cubed plus 4x squared plus 4x. And that's that multiplied out. Let's factorize this now. So we'll write this out again. So, first thing we look for when factorizing, is there a common factor? Well, clearly there's a common factor of x, we kind of know that. So we can take that out and get x squared plus 4x, essentially dividing by x when you're taking x out, plus 4. And then we can factorize this, guess how? As so, we know this is x and x, we want two numbers that multiply to give this, and add to give this. What numbers do that? Well, it should be plus 2 and plus 2. 2 times 2 is 4, 2 plus 2 is 4. So there we have that basic factorization, and of course we know that this can be written as so. And this are the same as expected. Alright, so that's how you do basic factorizing and multiplying out brackets. Very important. Let's move on and actually solve an equation. So how do we solve an equation? Well, we know how to solve one type of equation at this level, and this is an equation in the form ax squared plus bx plus c equals 0. The equals 0 is very important. And the solution to this equation is x equals minus b plus or minus, so we do plus and then we try the minus solution, the square root of b squared minus 4 times a times c. All of this, remember, all of this divided by 2 times a. Okay, so let's look at a quick example. Let's say we had something nice and simple, or maybe a little nasty to start with, but it's fundamentally simple. Plus 4x plus 2 equals minus 1. That's not 0. So what do? Rearrange it, make it 0. Add 1 to both sides, so we get x squared plus 4x plus 3. This and this are in the same form, so we can compare like so. So we can say, well, this is 1 times x squared is just 1 times x squared, so that's a, that's b, and that is c. So we can put these a, b, and c into this equation, so we can say that x is equal to minus 4 plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is 3, divided by 2 times 1. So x is equal to minus 4 plus or minus 4 squared, what's that? It's 16. Square root of 16 minus 4 times 3 is 12, and times 1, divided by 2. So that's minus 4 plus or minus the square root of 16 minus 12, which is 4, divided by 2. So come across here, just run out of space. So we can say that x is equal to minus 4 plus or minus 2 over 2. So let's just do the division by 2. So we can say that this is minus 2 plus or minus 1. So the two solutions, we've got two possibilities. We can do the add and we can do the subtract. You see plus or minus. So two solutions, we've got x equals minus 2 plus 1. So x equals minus 1. It's one solution. The other possibility is that x is equal to minus 2 minus 1. So x equals minus 3. And that's how you do it. This equation solved. One more thing, this bit here is the most important. So the square root b squared minus 4ac tells you a lot. So if this, let's call this a. So if a is greater than 0, we say there's 2 real roots. If a is less than 0, no real roots. We say real because the solution to this type will be something like 3 plus 2i, where I is the imaginary number. That's why we do it that way. And you don't have to know about imaginary numbers until advanced higher. They're a bit of a pain. And then a equals 0, there's 1 real root or equal roots. Alright, so that's how you solve equations, and a little bit about this, sometimes called the discriminant. So now let's finish by rearranging a really nasty equation, changing the subject of a formula, in other words. So let's quickly rearrange an equation, and this equation is going to be really nasty. And we'll do it quite quickly, and you can pause the video and you can follow through if you get lost. So we're going to do p equals the square root of p r over x minus q divided by z x minus t. Absolutely horrible. But it's not really. First thing, we can square both sides. So we can say that p squared equals pr over x minus q z x minus t. That gets rid of the square root. Next thing we can do, take something to the other side, take this to the other side. So we get p squared minus pr over x equals minus q z x minus t. We don't quite like this, so we can multiply through by minus 1. And so when we multiply through by minus 1, we would get minus p squared plus prx equals q over zx minus t. Right, this is slightly nicer. We can switch this round, so pr over x minus p squared equals q zx minus t. Next thing we can do is we can multiply through by z, so we get prz over x minus p squared z equals q x minus t. Next thing we divide through by q, we'll come across here, so we get prz over x q minus p squared z over q equals x minus t. Right, almost there. We don't really need the brackets now, so we just need to subtract an x from both sides, so prz over x q minus p squared z over q minus x equals minus t. So t equals multiply through by minus 1 minus pr z x q minus p squared z over q, sorry, this will be plus, and then we've got plus x, and that's the final answer. So hopefully this video has been helpful to you and you now understand more of National 5 maths. This is just the fundamentals. You've got more studying to do, but I really hope that this is going to speed up your studying because you now know the kind of most important stuff and you've seen at least one worked example of it. And finally, thank you for